kick off things.
Okay. Whoops. Okay, can everyone see the screen okay there?
Yep.
Okay, so thank you, Stephen, for the introduction, and thank you for inviting me to present today. And for everyone that's joined, thank you for taking the time, and I hope that this will be interesting for you. We can do questions and answers at the end, so if there's anything that you want to ask, we'll do that at the end of the presentation. So Daikin, not necessarily a household name to one and all. So I just wanted to give you a bit of background about the company. So it's a Japanese company. We will be the leading manufacturer of air conditioning and air to water heat pumps and technology generally for purifying air, cooling air, heating air, as well as ventilation products, refrigeration products, and so on. So the company was originally established in 1924 in Japan, and the technology ranges from equipment that can operate from an outside temperature of minus 45 degrees and can be built to suit any size building. So huge commercial buildings, manufacturing plants, down to your residential home. So a huge range in between. Daikin is working towards net zero CO2 emissions by 2050, employ 86,000 people approximately around the world, and are represented in 150 countries worldwide. So absolutely enormous. So one important factor is that all of the technology that we sell in Europe is manufactured in Europe. And this is really important because I suppose in the time that we're in now, where heat pumps are really starting to become the main technology for heating new buildings, as well as retrofitting older buildings, there's going to be a huge amount of new entrants coming into the market. And a lot of technology will come from China, it'll come from Japan, it'll come from Korea, it'll come from all over the world. And what's critical is that actually product manufactured in Europe for Europe it's developed, manufactured, R&D for our region and manufactured within our region to our specification standards, our EN standards, and so on. So we have our flagship factory is based in Ostend in Belgium. We have another factory in the Czech Republic. We have a factory in Germany. We have a factory in Turkey, and we have a new factory planned in Poland, which will open in 2024, and that is going to be dedicated specifically for heating products. So there's huge growth anticipated and being planned for within Daikin at the moment. So in Ireland, we have representation in Ireland, which is again an important thing when you're importing product into the country, that it is serviced and supported with the team within Ireland. So we have a product manager here that basically would concentrate on all the technical aspects of the products, new product launches, implementing new products into the Irish market. We have an in-house engineering team of 7. We have a sales support team of 5, external sales team of 6 people dedicated to heating products only. Our FQS team, which are the service guys that look after commissioning, service and warranty. We've 2 of those that cover the country. And we're continually recruiting for service, sales and engineering staff. And in the last 6 months, we have completed our showroom in our building in City West, which is a really nice, I suppose it showcases all our product, but it also is a training facility where we've been carrying out kind of 2 training sessions a week for the last 2 months since it was finished. So I'll show you some images of that as we go along. So one thing that is unique to Daikin, I should say, is that we manufacture both the refrigerant and the compressor. This is 100% unique to air conditioning and air to water heat pump manufacturers. And it means that we can stand over our compressors with total peace of mind. So to get on to air to water heat pump applications, the way that I look at it is we're separating them out into 2 categories. So we have new build and we have retrofit. And up to now, the new build heat pump sales is driven by compliance with building regulations, compliance with NZEB buildings, and with the renewable contribution that's required for new build. Retrofit is a whole new ballgame, This is whereby the government's climate action plan has a target to retrofit 400,000 heat pumps by 2030, and these must be fitted into existing dwellings to replace old, less efficient fossil fuel boilers. So new build applications. Building a new house, you're driven by compliance. As I said, your new house is going to be airtight, it's going to be highly insulated, it's going to have more than likely mechanical ventilation. You only need low temperature to provide the heat in this building. So that is a very happy marriage between a heat pump and the new type of buildings that we've been building in Ireland since 2019. The heating systems are designed and sized for heat pumps. So you're looking at, your radiator has been sized for a lower temperature, or indeed aluminium low temperature radiators, or underfloor heating, which of course is always a low temperature heating system, ideal for use with air to water heat pumps. One of the big things that we don't think of very often is the air quality around our homes. And when you have an oil or gas boiler, you have combustion of fossil fuels, and you may also have a solid fuel stove in your house. And all of this burning of fuel, it compromises the air quality around your home. So when you have an air to water heat pump, you have no concern about your air quality. You have one energy bill, which of course is a really a good way of managing your household bills. And you also have a highly efficient heating system. You're getting an efficiency of between 400% and 500%, as opposed to an efficiency of at best 97% from an oil or gas boiler. So for retrofit then, it's a little bit more complex because you're dealing with an existing building that has been built prior to the current building regulations. And in that regard, it's definitely recommended that you consider making your home more energy efficient before you install a heat pump. And this is very much the guidelines coming from SEAI, Sustainable Energy Authority of Ireland. So their recommendation is, if you want to put a heat pump into your existing home, that you should firstly carry out a technical assessment. And this is a survey on the fabric of the building. So it's going to look at the insulation, the quality of the windows, the amount of leakage of heat out of the building or air changes within the building. And they will provide a comprehensive report to say, okay, your house was built in the 1970s, you need to upgrade either your attic insulation, or maybe you need to put in, invest in external insulation, upgrade your windows, make your house a lot more airtight than it would have been, which will make your house more comfortable to live in, and also reduce your heating bills regardless of what your heat source is. So it's a really good investment in your quality of life when you're at home, in increasing the value of your home and decreasing the cost of your energy bills. So when you're looking at doing this retrofit, you also need to look at the existing heating system. Of course, it's not as straightforward now as a new build where everything is starting from scratch and you're designing this heating system around a heat pump. Now you're designing your heat pump around what's existing in the house. And in that regard, you may have to upgrade some of your radiators, change some pipe work, and change your heating controls as well. And to do all this, SEAI are providing grants. So if your house is fairly well insulated, it's up around a B2 level, you will qualify straight away for a heat pump grant. If it's lower than a B2, more than likely you're going to have to carry out additional upgrade measures. And you can have a look at the SEAI website and find out what the contributions are. There's €6,500 towards fitting a heat pump, but you may have to carry out additional upgrades before you qualify for that heat pump grant. And you'll also qualify for, external insulation, attic insulation, dry lining is another one on the insulation ones. So you can look at what updates are needed in your home, and you can make a plan. Maybe this year you do your insulation, and maybe next year you do your heat pump. So it's your retrofit journey, so to speak. The other option you have, if your house is very old and you have a lot of upgrades to do, you can look at a deep retrofit. And to do this, SEAI have a list of registered one-stop shops that will carry out the complete upgrade. They'll manage all the trades. They will manage all of the funding. So they'll apply for all the funding and you will only have to pay the net balance once all of the works are complete. So it's another good option if you're doing a big energy upgrade on your home. So just moving on to look at the different types of technology that we offer in Daikin. There's two main types of air to water heat pumps. You have a monoblock and you have a split. So with the monoblock, the whole idea is that all of the components of the heat pump system are in the outdoor unit. So you're using very little space inside for this type of heat pump system. It's a water-based system, so you're bringing a 1-inch connection into the house. It's split with a 3-port valve before it gets to the hot water cylinder, and that just means that the heat pump is going to divert between heating and hot water. So it'll never be providing heating and hot water at the same time. All of these systems are designed on a priority hot water, I suppose, system design. So if there's a call for hot water, the heat pump will go into hot water mode. It'll stop doing heating. Once the hot water requirement is satisfied, it'll go back to heating until heating is satisfied. So the monoblock range, it starts at a 4 kilowatt, which is for a small building, all the way up to 16 kilowatt. You can see two different images there of outdoor units. So the smaller white one is the smaller class 4, 6 and 8 kilowatt. The one with the black grill is 9, 11, 14 and 16. This is a new product that was launched. Both of them are actually, they both have R32 refrigerant, both launched in the last year. And the higher classification ones would ordinarily have been a double fan unit. They've been redesigned now into a single fan unit, so they fit under a window, which makes it quite convenient for locating the outdoor unit and keeping it close to the house as well. So the benefits of your monoblock, you're not taking up any space inside. All you have inside really is your hot water cylinder and your hot press or your utility room. You've water only connection between the indoor and the outdoor unit. And all of our heat pumps come with a built-in 3 kilowatt backup heater. And that's there as purely as a backup. It assists when the heat pumps are initially being commissioned. So this time of the year specifically, if you're turning on a heat pump for the first time, you need the water in the system must be above, I think it's 12 degrees. So the compressor will not run until the water temperature flowing around in the system is above 12 degrees. And the backup heater assists in allowing that to come up to temperature rather than waiting. Sorry, I'm having a bit of an error here. Rather than waiting for, because obviously the water and the temperature this time of the year is very cold. Sorry. There's a bit of an exception happening here. So that's the monoblocks. They're ideal for retrofit scenarios because you're not having to fit in any unusual size indoor unit in a space that you don't have available. So one thing to note about all of our heat pumps, they operate down to minus 25 degrees, and all of these ranges will give you a leaving water temperature of 65 degrees. So there's plenty of scope in between for fluctuations in your flow temperature. Refrigerant splits. So this is the alternative to a monoblock. You can see that the outdoor unit is more compact, and that's because your hydraulic components and your PCB boards, your backup heater, heat exchanger are all built in to the indoor unit. So when you look over here at this tall indoor unit with the black control panel on the front, this is what we call an integrated indoor unit. It houses your domestic hot water storage, so you can have 180 litres or 230 litres of hot water storage. This smaller unit beside it, which looks like a gas boiler, is a wall-hung version. So this wall-hung unit, it houses all the hydraulic components, heat exchanger, backup heater, etc., and allows you to put a separate cylinder in a different location. And again, this is just giving you different options for how you manage the location of your indoor units. Refrigerant splits generally give you the best efficiency. They give you a higher efficiency over a monoblock, generally speaking. And they also allow you to have a longer distance between the indoor and the outdoor unit. So it allows you to have about 30 meters of a pipe run between the indoor and the outdoor, whereas the monoblock, you're really restricted to about 10 to 12 meters. So that's the refrigerant split. The indoor units, as I said, you have your floor standing indoor unit. The beauty of this one is it has the same footprint as any white good, so it's 600 by 600. These are generally located in certainly in new build applications, they would be in the utility room, and they fit very nicely in with the rest of the white goods in that room. They're available in a heating only model or a heating and cooling model, which is handy. I mean, cooling is beginning to become an issue for us here in Ireland because houses are so well insulated. So if you want to incorporate cooling as part of your overall heating system, we supply a reversible unit which allows you to do cooling as part of the same system. Your wall hung unit, as I said earlier, it just allows you to have a separate cylinder in a separate location. And it can be a very convenient system to be able to use when you can't fit the floor standing unit in one location. The final model that I want to show you is our high temperature split. So this will provide up to 70 degrees in leaving water temperature and operates very, very efficiently in very low outdoor temperatures. And the reason for that is it was specifically designed for the requirements in the Nordic countries where they regularly do have very low outdoor temperatures. And one of the other design criteria was that this would operate with very, very low outdoor sound levels of the outdoor unit, sorry. So you can see that the sound levels there, 35 decibels, which would be considered extremely low for heat pumps generally. The reason that that's important is in Nordic regions where you have very densely populated areas, heat pumps would be probably the most common heat source. And at night time, there's actually restrictions on noise levels of outdoor units. So for that reason, the noise levels of this unit was very much a part of the design. So we don't have a huge market for high temperatures heat pump in Ireland because when we're looking at retrofit, we're generally upgrading our buildings to make them more energy efficient, and therefore our low temperature heat pump range is actually suitable to match the building. So the high temperature, it's only used in very specific circumstances. If you had maybe a period house where you have old cast iron radiators that can't be replaced, or you just want to keep them, by taking out the boiler and putting in this high temperature split, you're getting a like for like system where you can still run those radiators at the same high temperature. So from that point of view, it's a really good solution. It comes with the same indoor units, again, the integrated indoor unit and the wall hung. So it allows you to locate your indoor units in whatever combination suits best. One other solution that's quite interesting, we're selling quite a lot of these systems at the moment. It's an air-to-air heat pump. So this would be traditionally kind of known as an air conditioning system. When you go on holidays to Spain and you see the air conditioning unit inside in the apartment, that's actually a unit that can also do heating, and they're starting to be used a lot more for heating. So they can do heating and cooling, obviously not at the same time, but the same system can do heating and cooling. And they're ideal as a replacement for storage heaters. And we supply a lot of these into social housing units when they're doing energy upgrades. They're taking out storage heating, and air to air is a much more easy integration when you've never had a wet system in the building. So instead of putting in pipework for radiators or digging up floors for underfloor heating, this is a much, much handier system. So you can have you can have up to 5 indoor units with 1 outdoor unit. Or when you look at the next slide here, we can actually combine a hot water cylinder with these indoor units. So when you combine the hot water cylinder, you can only have 3 indoor heating and cooling units. But when you put this whole system together, you now have a highly efficient heating, cooling, and domestic hot water system that's very easy to install into an existing building where there has never been a wet system. They're also been used actually in new build apartments and the likes of, we'll say, small holiday homes, or if you were putting maybe like a cabin or an outdoor room as a home office or something like that. This is an absolutely ideal solution. So that's the technology part of it. Just to go through some pointers on how you should run your heating system. So in most heating systems, certainly in new build applications, you're going to have room thermostats, or you're going to have TRVs on your radiators, and these are used to set the desired room temperature. And those desired room temperatures for living areas, you're looking at 19 or 20 degrees, and for bedrooms, 17 to 18 degrees. It's important to say that by reducing the temperature on your thermostat by 1 to 2 degrees will improve the efficiency of your heating system. And I know that's something that's everybody's concerned about at the moment with the increase in energy costs. So once your heat pump is commissioned, you shouldn't really need to make any adjustments to the settings on the heat pump. So if your heat pump is commissioned by a commissioning engineer, they will go in and they're going to set up what we call a weather compensation curve. And this is by far the most efficient way to run your heating system. A weather compensation curve takes the outdoor temperature into consideration when it's given the flow temperature into your radiators or underfloor heating, and it can fluctuate by plus or minus 5 degrees in most cases. So today it's cold outside, it's going to be putting a higher flow temperature into your heating system than it was last week when it was, say, 16 degrees outside. So it gives that fluctuation, and it means that the heat pump is always matching the flow temperature in the building to what the actual outdoor temperature is. So you've got a really nice synergy going on there. So the most efficient way then to manage your room temperature is to set your room stat or your TRVs to, say, for your living spaces, set it at 19 degrees or 20 degrees and allow the heat pump to maintain that temperature. So it is a kind of a foreign concept to anybody who's used to running an oil boiler, because the norm would be to turn it on and turn it off as quick as you can so that you don't use too much oil. But with heat pumps, actually, you want the heat pump to run and not to be doing really hard work all the time. And to do that, you maintain the temperature. And even though it seems like a crazy thing to do, it actually is the most efficient way to run your heating system. Just let it maintain the temperature, and you'll have constant comfort in your house. You're not going to have fluctuations in, the house is hot, the house is cold. You're going to have a continuous stable temperature and a really comfortable living environment. And that's a really, really nice thing to experience. I've just renovated a property myself and put in a heat pump, and I can absolutely stand over this as a really good way of managing your heating system and for the efficiency of it as well. So just two other important factors. It's really important that you don't turn off the power to your heat pump, because your heat pump has programs built in to manage it and certainly to protect the compressor. So when there's very cold temperatures outside, you're going to see a lot of water running off the heat pump. And during times of high humidity, you're going to see a lot of water running off the heat pump. And it's important that water can flow easily away, that it doesn't sit underneath the heat pump and start to freeze back up into the heat pump. If anything like that starts to happen, the heat pump has its own program built in, electronic functions to protect the compressor. And provided that there's always power to the compressor, it's always going to protect itself. And then the other important point is that you keep the outdoor unit clear at all times. You don't put a trellis and some nice trailing shrubs up around the heat pump to cover it because you don't like the look of it. Unfortunately, these are a part of our lives now. We have to keep them clear. We have to allow for the air to circulate freely around. So the heat pump pulls in the air at the back of the heat pump and it extracts it out the front. And you must have a clearance of at least a meter and a half in front of the unit at all times, because otherwise the air that's extracted from the heat pump is going to recirculate back into the heat pump, and you're not going to have any energy to strip off of that air. You're just going to have cold air recirculating. Your heat pump is going to go out in a fault and it's not going to be efficient and you're going to have problems. So really important. There's constant power, and there is the heat pump is kept clear, and there isn't any restrictions around it. Domestic hot water production is fully managed by the heat pump schedule, so it will allow you to set your schedule for morning and evening, or you can use a reheat function. This allows the tank to drop by 10 degrees and then reheat to the set temperature of the tank. You can use both functions together so you never run out of hot water. The ideal tank temperature for efficiency is 48 degrees, and there is a disinfection function that's factory set for once a week. It'll heat the tank up to 60 degrees and hold it there for 10 minutes. That's an anti-Legionella function. And on the Daikin heat pump, the black panel on the front, we call it the Daikin eye. It is the controller of the heat pump, and it will show you if there's a fault on the heat pump. The Daikin eye will be red when it's in normal working functioning mode. It will be in blue. So just images, I'm looking at the time ticking down here, so I'm starting to speed up. Some images of how the outdoor unit should be installed, and you can see there it sits on the rubber feet. They're anti-vibration feet so that the vibrations are not going to damage anything internally in the heat pump. You've got some a drain underneath the heat pump so that the water can drain away from the heat pump when it starts to run off. And then you can see the really nice integrated indoor unit. It just fits in to a cupboard, and it's taken up the same footprint as the tumble dryer next door to it. Another image here, what I'd point out here is the pea gravel around the base of the heat pump. That's a really good way of having drainage of the water away, freely draining away from the heat pump, which is a really good way to do it. And this shows the integrated, the wall hung indoor unit with a separate cylinder and nice neat pipe work around that. So a case study here from a deep retrofit project. This was originally a D1 BER rating. It's a 1970s built house. Their upgrades were external wall insulation, triple glazed windows, a composite front door, demand controlled ventilation, and a Daikin heat pump. And they went from a D1 to an A3, and their running cost of the heat pump is approximately €1,200. This is a similar one again, actually, 1970s house, 1,200 square foot house. There was a gas boiler and a gas fire. It had a BER rating of E2. And with the upgrades that they carried out, again, it was external insulation, new windows and doors, attic insulation, Daikin heat pump. They've brought that building up to a B1, and their monthly electricity usage for all of their heating and all of their electricity use and domestic hot water is about €98 a month. And that was for January and February. So high levels of heat required. This is just giving you an idea of what our training centre looks like in Dublin. We have the training classroom, and we also have all of our heat pump models on show. You're welcome to come and sign up for training if you wish. Training@daikin.ie is our training email. And as I said, we've working models. We're doing training there a couple of times a week. So please put your name down if it's something you'd like to do. And any questions? It looks like we're running out of time here, so I'll hand over to you, Stephen, for any questions.
That's perfect. Thanks, Daryl, for.
Sorry, I feel like I was racing towards the end.
It's okay. It's okay. There's some pretty good questions going in here now. If you,
okay, I'll stop sharing here.
So we have one from Kieran says, oh, sorry, it's that's moving there for me. Do you arrange full installation, including all plumbing and wiring? And in older houses, do you need to have a wiring upgrade or a special MCB installation?
Yeah, that's a really good question, actually. So first of all, we are the manufacturer, so we do not install. We would have a network of installers around the country, and if you check our website, it's currently the map is being updated, but our suppliers and our installers are listed on a map. And if you go into, I think there is a section, if you go to the supplier list, you'll see all the places where you can buy our products. In relation to upgrading your connection, the answer to that is it needs to be checked, because in older buildings, quite often the supply into the building won't be good enough for a heat pump. So that is something that needs to be checked. A 12 kVA line will suit all of our single phase products. So you do need to check that. MCBs most definitely will have to be upgraded as well.
Perfect. Another one here is there just one information badge on top the split unit? Sometimes it can be covered by the built-in kitchen. Is there a badge inside for BER purposes?
No, there isn't actually. The badge is on the top of the unit. Another very good point. And actually, in the image that I showed you, probably would one thing that actually we do recommend is if it is being built into a unit, that there is a shelf left on top that can be removed, because if you need to service the heat pump, you have to be able to get into, you have to be able to take the top off and the front control panel off. But that is where the information badge is. But if you ever need any information, feel free to contact us, because we have everything on file and we can send it to you in 5 minutes. So if you ever need anything, just give us a shout.
Perfect. Now we're running low on
We're
time
getting
here.
close. We're getting close. Yeah.
There's one more question. So I was like, would there be a difference in efficiency between the high temperature and low temperature units? And it says in a standard timber frame house built around 2000. So I'm guessing.
Well, yes, of course, because if you're like, the whole idea with heat pumps is you want to run them at low temperature, and that's where you get your efficiency from. Now, the high temperature units, like, they're a brilliant solution because it's allowing you to get rid of fossil fuels. It's allowing you to have a heat pump system. It's allowing you to have an efficiency of maybe, 275% instead of maybe 400%. So the efficiency is lower. As I said, those particular high temperature units, they operate really, really highly efficient at very low outdoor temperatures. But that's not our market. That's not our need as such. So some of the low temperatures still will give you 65 degrees, and they probably are better suited to our climate. But the efficiency, yes, the efficiency of low temperature is higher than the efficiency of high temperature for sure. Yeah.
Perfect. With that, I'd like to thank April for making a nice quick presentation, and I'd like to thank everyone for joining us today. We'll be kicking off next week with more Heat Pump Association members. We'll be running through their products and their control settings too. So thanks everyone, and have a good day.
Thanks guys, and thanks for joining. Take care.